The second half of section 2.6 involves factoring again, but this time we're looking at equations. And so in order to solve equations, just like we did in section 2.5, we have to make sure that whatever our polynomial is has to equal 0, because the zero product property tells us that anything times 0, so let's say 0 times x minus 5, doesn't matter what x minus 5 is, the whole thing will be 0. Or if it's like 2x minus 2, if whatever's in the other parentheses makes that set of parentheses equal 0, the whole thing will be 0. And so we'll look for two factors, set them each equal to 0, and solve our equation. So for this first one, my first step is always to look for a greatest common factor. So I'm looking at 3, 4, 15. Nothing goes into all three, and they don't each have a variable, so I can't bring out a variable either. So I'll just go right into the factoring. At the top of the x, we'll do a times c. So in this case, 3 times negative 15 will give me negative 45. And in the bottom of the x, we will have the b term, which is negative 4. So at this point, we're thinking of the factors of 45 and what would multiply to give me negative 45, but add to give me negative 4. So the bigger this number on top is, the harder it might be to come up with those two numbers. So a good thing to do would be to list the factors. So we have 1 and 45. Those wouldn't work. 2 doesn't go in. 3 does. We have 3 and 15. Those could not get you to 4. So it's not 3 and 15. 4 doesn't go in there. 5 does. We have 9 and 5. And 5 and 9 will be the ones to give you 4. So what combination of 9 and 4 or 9 and 5 would give you a product of negative 45 and a sum of negative 4? That would have to make the 9 negative. And then I can draw my box. So in the top left corner will be the ax squared term. In the bottom right will be negative 15. And then I'll put the remaining factors that I came up with and the variable. And then I'll bring out the greatest common factors. So in the top row, right here, 3 and 5 don't have a common factor, but x goes into both of x squared and x, so that's going to be x. In the left column, the GCF is 3x, and that works because 3x times x gives me 3x squared, so that will work. In the bottom row, we'll look at the GCF there. I'm trying to get negative 9x in here. So the only way to do that is to multiply this by negative 3. And that checks out as the GCF. And then in the last column, we would have a positive 5. So we should make sure that when we multiply x times 3x and x times 5 and 5 times negative 3 and negative 3 times 3x, that we get the results in the box, and we do. So my answer would be x minus 3 times 3x plus 5 equals 0. So how do we find x? There's going to be two possible solutions. Either x minus 3 equals 0, which would make the whole thing 0, or 3x plus 5 would equal 0. And then we solve for x. So x is either 3 in the first case, or in the second case we subtract 5 from both sides and then divide by 3. So x is either 3 or negative 5/3. And those would be my two possible values of x. So we're just adding one layer to this. After we factor, we still have to solve for x. We keep going and look for a GCF. So 2, 13, and 24. 13 is prime, so nothing goes into all of those. I'll go right into my factoring. On the top we have 2 times negative 24, which is negative 48. On the bottom we have negative 13. This one, again, we can look at the factors. We have 1 and 48. Those don't work. Those don't give us 13. We could do 2 and 24. Those also wouldn't give us 13. We could do 3 and 16. And these do work. To get 13, which one has to be negative? Well, if the 13 is negative, the 16 would have to be negative for them to add to negative 13. And then I'll draw my box. In the top left, we'll have 2y squared. In the bottom right, we have negative 24. And then my remaining factors here, 3y and negative 16y. The top row greatest common factor is 2y. The first column is just y. 2 and 3 don't have a common factor, but y squared and y do. And then the bottom row is going to be 3, and the right column would be -8. So you might notice that 4 and 2 go into both 16 and 24, but we also have to remember that I have to multiply by 2y to get what's inside here. So the only way to do that is multiply by -8. So my equation would be 2y plus 3 times y minus 8 will equal 0. And 2y plus 3 equals 0, or y minus 8 equals 0. So when I solve for y, I'll get 2y equals -3, which gives me y equals -3 halves. Or the other one, very simple, y will equal 8. So these are my two possible solutions there. A couple more. So again, I'm looking for the GCF first. So if I think about these three numbers, what goes into all three? Well, we can factor out a 6, and inside the parentheses we would be left with y squared minus 4y plus 3 equals 0. So I have to remember that that 6 is out there, but the factoring is now pretty easy because in the top of the x we would have just a 3, and in the bottom a -4. So obviously it's going to be 3 and 1, but because this 4 is negative, these both have to be negative as well. So this polynomial has a leading coefficient of 1, and so I can just go straight into my factors. Y minus 3 times y minus 1 times 6 would equal 0. Now this 6 doesn't really affect the values of y, because still if one of these is 0, the whole thing's going to be 0 even though you're multiplying it by 6. So the 6 doesn't really affect my answer. But if I was just asking you to factor, you would have to include the 6. So my two possible solutions are y equals 3 or y equals positive 1. And that's it. And we'll look at one more example. My GCF, is there one? 13 and 5 are prime, so there is no GCF, but I can factor. On the top would be 6 times 5, which is 30, and on the bottom would be 13. So these two numbers, 6 and 5 don't work, but 10 and 3 do. Everything's positive, so that's pretty nice for us. And then in my box we would have 6r squared in the top left, 5 in the bottom right, and then we would split the 10r and the 3r. And then in the top we'll bring out a GCF, so we have 3r on the outside in the top row, a 2r in the first column, a 5 for the bottom row, and a 1 for the rightmost column. And then we'll write our factored form and set it equal to 0 and find the two values of r. So these are both going to be fractions, but 3r plus 5 will equal 0, and 2r plus 1 will equal 0. So when we solve for r on both of these, we'll get r equals -5/3, or r equals -1/2. And those are your two values for r.